Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Till you are going to report me this, let me just brief you what is the ideal duration and what is the agenda for today's session. Friends, the ideal duration for today's session is going to be approximately 45 minutes, and the agenda or the outcome of the session is that today we are going to practice some of the important basic problems related to transmission line basic concepts that we have discussed in the previous session. In this particular series, BYJU'S Exam Prep is providing you the complete preparation for your GATE 2023 examination. In this regard, we have started with one of the core subjects for all electrical engineers, that is power system. We have already completed 2 sessions on that. In the first session, we have talked about what is the preparation strategy, important books, and what has been the weightage for power system as far as the previous year GATE examinations are concerned. In the second session, we have talked about some of the basic concepts of designing part of the transmission line. Today we are going to discuss some problems related to that, and we will do some problems related to the line constant calculations also. With the help of these problems, you will be able to understand the concept well, and the most important part is you will be having better confidence as far as this particular subject or topic is concerned. So all the candidates who are joining me live, just quickly comment in the comment section and mark your presence. Yes, Ashish, welcome to the session. But before we start, it is very important that you just quickly hit the like button, hit the bell icon, and subscribe to BYJU'S Exam Prep if you have not subscribed till now, so that you get all the important class notifications in time. Do not forget to share this video with your friends and colleagues so that more and more people are going to be joining with us. So I'm assuming everything is clear, and let us quickly start with the session. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from BYJU in 2010. I have written a couple of books also on engineering ethics and power system. My areas of expertise are power system, electrical machines, electromagnetic field theory, material science, and obviously engineering ethics. Before we start, I want to make a proud statement about the exemplary result we have got for the GATE 2022 examination. You can see on the screen 41 selections we have got under rank 50, 11 selections under rank 10, and 74 selections under rank 100. It has been the history of BYJU'S Exam Prep to produce such an exemplary result in various exams, and GATE is not an exception. So friends, with these words, let us try to understand what is the agenda for today's session. The agenda for today's session is, once again I am telling you, we are going to discuss some of the important questions, problem practice we are going to do for transmission line for your subject power system as far as GATE 2023 examination is concerned. Let us start with the first question. Everybody who is joining me live, just quickly comment everything is okay, and shall we proceed. The first question talks about for the same power transfer and the same efficiency. So there are 2 conditions given. Number 1, same power transfer and same efficiency. He is saying if the operating voltage of the line is increased by 3 times, then the area of the cross section of the conductor is reduced by. So let us try to figure out what the question is saying. Suppose you have 2 conditions. In the first case, suppose the voltage is V1, I1, and the current, voltage and current is V1, I1 for the first case, and voltage and current are V2 and I2 for the second case. He is not giving any information about the power factor, so I am not going for the power factor, and you can assume also that the power factor is unity if no information is given like that. The first condition he is saying for the same power transfer. For same power transfer, what is the equation you are going to write? For same power transfer, In the first case, power V1 I1 is equal to V2 I2. He is also giving you one information about the voltage. He is saying the operating voltage of the line is increased by 3 times. It means he is giving you information that V2 is 3 times V1. So this is the second information. By using this information, by using this information, you can relate the current in the two cases very easily. Yes. So can I write I2 by I1 is equal to V1 upon V2, or you can write it as 1 upon 3. Is it clear, everybody? Let us go for the second condition given in the question. The second condition is saying same efficiency. Now, when the same power transfer is there and efficiency is also same, it is only possible when the losses in the two cases, two conditions are going to be same. So, if you want to write the loss in the first case is equal to the loss in the second case. How you can write the loss? You can write the loss as I1 square R1 is equal to I2 square R2, where R1 and R2 are the resistances for the two cases. So you can write it as R1 is equal to I2 upon I1 square, and this is going to be R2. Now you know R1 and R2 you can write as rho L upon A1, and this is going to be, what is I2 upon I1? Can you tell me? I2 upon I1 we have figured out as 1 by 3. So this is going to be 1 by 3, and this is a square. And what is R2? Rho L upon A2. Now see properly, no information is given about the length of the transmission line. But anyhow, because you are not changing the length of the transmission line, so it is going to be same for both the cases, and it is automatically going to be cancelled. So no need to worry about it. The resistivity of the material is not changing because the material is same for both the cases. In the question, he is nowhere saying that the transmission line conductor material is changed. So the resistivity is also going to be same. So this is also cancelled. So now you can relate A2 and A1. So can I write A2 is 1 upon 9 times A1. Everybody just tell me in the comment section, are you able to follow this? Everybody just tell me in the comment section, are you able to follow this? See, if you are not active in the comment section, then there will be no positive conclusion of these efforts. It is going to be just a quorum. If you want some positive output out of these efforts that we are making together, then you have to be much more proactive in the comment section. Is it clear, everybody? So what is going to be your answer? It is reduced by 9 times. What is the second question? Now the second question I think everybody can answer. Very easy, direct theoretical question, but it is important, and it is about the understanding we have developed in the previous class. He is saying, what is the main advantage of using bundled conductors? In the previous class, I told you that when we talk about the bundled conductors, what is the first thing which should come to your mind? Yes, everyone? Why we are going for the bundled conductor? We started with the single solid conductor. We then went to the stranded conductor, and from the stranded conductor, we went to the bundled conductor. From the single solid conductor, we went to the stranded conductor in order to reduce the skin effect. While we were trying to reduce the skin effect, we got two more problems. Mechanical strength was reduced, and possibility of corona was increased because the surface is going to be non-uniform for the stranded conductor. In order to reduce the corona or the intensity of corona, we are talking about bundled conductors. So the first thing which should come to your mind when you talk about the bundled conductor is that GMR is increased. How GMR is increased? One single solid conductor is broken into smaller conductors, and they are given some spacing 1, 2 up to n. This is how we are saying we are having bundled conductors. Yes, Ashish, perfectly right. GMR is increased. Only one candidate is able to respond and rest are just sleeping. No problem with that. Now, what you are doing by increasing the GMR, if you write the electric field stress at the surface of the conductor, you can write V phase GMR ln GMD upon GMR. Now this is a logarithmic term, so it is not going to affect too much, but if you are increasing the GMR, definitely the electric field stress at the surface of the conductor is reducing, and if the electric field stress is reducing, definitely you can say the effect of corona or the intensity of corona or the corona loss is going to be reduced. This is our agenda. Is it clear, everybody? Just tell me in the comment section. What is the main reason why we are going for the bundled conductor? What is the main advantage? It reduces the surface electric stress on the conductor. Yes. Increases line reactance. Let us talk little more what is happening with the bundled conductors. You are saying by using the bundled conductors, you are increasing the GMR. What is the inductance per phase? In general, what is the formula? It is 0.2 ln GMD upon GMR. It is millihenry per kilometer. So if you are increasing the GMR, definitely the L per phase is going to be reduced. This L per phase can give you the reactance, that is omega L. So if the L per phase or the inductance is reducing, definitely the inductive reactance is also going to be reduced. But in the question statement, he is saying that line reactance is increased, which is wrong. He is saying decreases the line capacitance. Let us talk about the line capacitance also. How you are defining the line capacitance? In general, we are defining the line capacitance as 2 pi epsilon naught upon ln GMD upon R, and this is farad per meter. Now some of you may be surprised when we are writing the inductance equation or the inductance formula, we are using the term GMR. But when I am writing the capacitance formula, I am not writing GMR, I am simply writing R. What is the reason? The reason is this R is actually same as you calculate GMR, but it is without 0.7788 factor. What is the reason? It is without 0.7788 factor. What is the reason why we are not using the factor 0.7788 when we are dealing with the capacitance? The reason is when you talk about the capacitance, you talk about the electric field. And you know that electric field can't be present inside the conductor. Are you getting that? When you are dealing with the inductance calculation, then you are dealing with the magnetic field. Magnetic field or the magnetic flux can be present inside the conductor, and that is the reason while doing the inductance calculation, we are talking about both internal flux and external flux. But my friend, when you are talking about the capacitance, you are talking about the electric field or the electric flux. Electric field or the electric flux cannot be present inside the conductor. The best real life example for this is if you are talking to somebody and you are going to enter your elevator or the lift, you will see suddenly there is a steep decline in the intensity of the signal that you are getting. Why that is happening? Because there is very heavy attenuation, because your lift or the elevator is covered with the metal sheets. Are you getting that? So that is the reason. So because internal flux is not present, that is why we are not using this factor 0.7788 when we are dealing with the capacitance calculation. Simply we are writing as R. Suppose you are going to face the UPSC examination. The moment they ask you to write down the capacitance calculation equation, and if you write GMR here, their next question will be what we have discussed. But if you write this equation, the chairman of your interview board is going to go gaga. Gaga means he will start jumping from his chair. He will become so happy. And you have to control his emotions because he may start crying on your shoulder. So you have to control his emotions. Is it clear? Now you are saying that the GMR is increased. If GMR is increased, this factor is reduced. If this factor reduced, capacitance is going to be increased. But the problem statement is saying line capacitance decreases. So this statement is also wrong. None of the above, this is also wrong. So what is the best answer? The best answer is it reduces the surface electric field stress. And the ultimate consequence is by using bundled conductor, the intensity of corona is going to be reduced. Everybody just tell me in the comment section. And if you are able to follow me, do not forget to send me heart symbol in the comment section so that I am also motivated. If I am motivated, then I can motivate you also. Is it clear? Are you able to follow me? Just tell me in the comment section. Yes, everyone. Let us go to the next question. The next question again talks about when a fixed amount of power is to be transmitted, then the efficiency of the transmission increases when? Now this is one of the previous year GATE question. I hope you must have attempted this. Now please try to understand. If you observe the options given in the question, he is talking about the voltage and the power factor. So when he is talking about the voltage and the power factor, definitely you can say that he is talking about the operating condition. He is not talking about the design condition. Yes or no? He is talking about the operating condition. So the first thing you have to understand in this question is that the question is talking about the operating condition. Operating condition, if I want to write the losses, how you can write the losses? It is going to be I square R. But you know the resistance of the line or the conductor is not going to be changed at the operating stage. Once you design the line, once you fix its length, cross-sectional area, material, the resistance is going to be fixed. We are not including skin effect here until and unless given in the question you will not take into account the skin effect or the proximity effect. So you are saying resistance cannot be changed at the operating stage. It means resistance has nothing to do with the losses, and you can simply say the losses are going to be directly proportional to the square of the current. Now you know that efficiency and losses are going to be inversely proportional. Now you are saying efficiency of transmission increases. Efficiency of the transmission can be increased if the losses are reduced. Losses can be reduced if the operating current is reduced. And how you are going to write the operating current? Operating current you can write as, for a three-phase system, root 3 V cos phi. Now in the question he is saying the fixed amount of power. Fixed amount of power means this P is going to be constant. And in order to increase the efficiency, you have to reduce the loss or reduce the operating current. So if you want to reduce the operating current, you have to increase this factor. Now this factor can only be increased with 100% surety when both voltage and power factor is increased. Everybody just tell me in the comment section, are you able to follow this? So what is the best answer you can have? Voltage increases, power factor remains same, wrong. Voltage increases, power factor increases, perfect. Voltage decreases, wrong. Voltage constant, wrong. So what is the best answer? The best answer is B option. Is it clear? Everybody just tell me in the comment section. Are you able to follow this? I am not getting enough response in the comment section. So that maybe you are not finding the question interesting, or you are not finding the explanation or the concept interesting. If that is the case, then you can ask me if you have any doubt. Whatever concept question I am discussing, if you have any doubt, I will be more than happy to take up your doubt. I am not here just to solve any question. I am here to help you and give you the right direction. So if you are having any doubt, do not fear. This is the beauty of, you can say, online education. You don't need to fear. You can open-heartedly you can ask your questions. Let us see the next question. The next question is going to be a cakewalk for every student. He is saying what is the function of a steel wire in the ACSR conductor. I told you what you are doing in the ACSR conductor. In general, if you talk about the stranded conductor, yes, Mr. Shivam. See, one thing you understand, repeatedly I am saying please comment, but nobody is commenting. You know why this is happening? I am not telling it personally to you, but you know there are some candidates who are KG fail. Now you may be surprised how somebody can be failed in KG. It happened with some candidate. In the question paper of his KG examination, he was asked to write ABCD, but he did not write anything, he or she. You know why? Because he or she was confused whether it is uppercase or lowercase, whether it is big ABCD or small ABCD. Why I am telling you this story? This story I am telling you is until and unless you come out of that shell, until you open that restriction, the glass ceiling, you will not be able to remove your doubts. So explore the heights, and whatever doubts you are having, do not forget to ask your doubts in the live class. That is very, very important. Is it clear, everybody? Just tell me in the comment section. So I hope nobody is KG fail in my class. Is there KG fail in my class? I hope no. So my friend, stranded conductors you can have of two types. First one is homogeneous stranded conductor. What is the best example of homogeneous stranded conductor? It is going to be AAC. This is the best example. What is this AAC? This is all aluminum conductor. So just to show you, your all aluminum conductor is going to look something like this. All these strands are going to be of aluminum. Is it clear, everybody? Just tell me in the comment section. Now the second type of stranded conductor we are having is the composite stranded conductor. This composite stranded conductor, best example is ACSR conductor. What is ACSR conductor? It is steel reinforced aluminum conductor. How it is going to look like? It is steel reinforced aluminum conductor. So basically what we are doing, because we are saying that in the stranded conductor the skin effect is reduced, it is not removed. It means still the skin effect is present. In the last class I have discussed what is skin effect. If the skin effect is present, it means no significant current is going to flow in the core strands. So what I am doing, this core strand I am removing and I am placing some of the steel strands. Why I am putting steel strands? Because I want to increase the mechanical strength. Is it clear, everybody? Just tell me in the comment section. So this is your steel strand and this is going to be your aluminum strands. Everybody just tell me in the comment section, are you able to follow? This is going to be aluminum and this is going to be steel. So what is the basic purpose? There's some problem with the electricity. Okay, just give me a moment. Let me just figure out. Everybody just tell me once again whether my audio visual quality everything is clear so that we can resume the session. See, there is a saying in Hindi, मुद्दई लाख बुरा चाहे तो क्या होता है, वही होता है जो मंजूर खुदा होता है. And whenever you are getting problems in your path, do not fear, do not worry, do not become impatient. This is just a God symbol that whatever you are doing is right. You are on the right path. I hope you are getting my point. Is it clear, everybody? Everything is clear now? Shall we start again? Okay. So we were talking about the ACSR conductor. What is the main advantage? The main advantage is compensation for skin effect. No. Take care of surge. No. Reduces the capacitance inductance. No. Additional mechanical strength. Yes. D is the correct answer. Is it clear? Let us go to the next question. Next question, he is saying for a stranded conductor of 6 layer, the total number of individual wire or the strand will be. So let me just give you some idea about this. If you talk about the stranded conductor, suppose it is looking something like this. If you observe, whenever I am drawing a stranded conductor, I am always using 6 strands in the second layer. The core strand is only 1 and the next layer is 6 strand. Now some of you may be thinking, why always sir is writing 6 strand? There may be other also. No, this is not possible. For a given dimension, whatever dimension cross section you are going to take, there is one important rule, that is the pattern of strands. What is the pattern of strands? The patterns of strands will be something like this. 1, because the first strand is core, then 6, and after 6 it is going to be in the multiples of 6. No Ananya power system book is not in the market. Okay. It is still not possible because hardly I am getting time to figure it out. Engineering ethics is already in market. So it is 1, 6. Now the multiples of 6. 12, 18, 24, 30, 36 and so on. Then you have the total number of strands. There is a formula. Please use this formula wisely. If n is the total number of strands, the formula is 3n square minus 3n plus 1. But you have to understand that this n is going to be 1, 2, 3 or so on, where 1 represents the core, second stands for the second layer, and core we are assuming as the first layer. You have to understand this. The counting of layer, we are starting with the core. This is very, very important. In some of the books, they are starting the counting of the layer from the second one. So their formula will be little bit different. So don't get confused. Are you getting this? So if you use this formula, what are the number of layers he is saying? Total number of layers are 6. So what is going to be total number of strands? 3. Number of layers 6. So 6 square minus 3n, 3 into 6 plus 1. So if you solve this, I hope you must be getting as 91. Is it clear, everybody? Just tell me in the comment section, are you able to follow? There is one more information or concept, that is the total diameter. The total diameter is given as capital D is equal to 2n minus 1 D, where D is the diameter of individual strand. Individual strand. I hope you are getting it. Definitely, Ashish, if you want the PPT or the PDF for this session or any other session, for my session, you can join my personal Telegram channel that is available on BYJU'S Exam Prep, that is on Telegram. It is Electrical by Ashutosh Saxena. Just after the session, I will be uploading the PPT or the PDF, don't worry. If you want to prove this formula, suppose you want to prove this formula, let us talk about this. If this is the diameter of individual strand, this is the diameter of individual strand, this is the diameter of individual strand, so what is going to be the total diameter? The total diameter is going to be 3D. If you put it in the formula, how many number of layers you are having? The core strand stands for the first layer. The next one is the second layer. So total how many layers are there? 2 layers. So if I write the formula, D is equal to 2 into 2 minus 1, and that is D. So this comes out to be 3D. Is it clear, everybody? Just tell me in the comment section. Are you able to follow this? So see the next question. Next question, he's talking about the total diameter. Now I think everybody can answer this. He is saying total 3 layers are there and each strand diameter is 5 mm. So what is going to be the total diameter of the standard conductor? It is going to be 2. N is the number of layer, that is 3 minus 1. An individual strand diameter is 5. So 2 3s are 6 minus 1 is 5. So this is 25 mm. So what is the answer? B. Is it clear, everybody? Just tell me in the comment section. Shubhadeep Mandal is saying Pranam Gurudev. आशीर्वाद आशीर्वाद, ढेर सारी बधाइयाँ, शुभकामनाएं, आशीर्वाद आपको, इतना सारा आपने गुरुदेव लिख दिया. Thank you so much for your love and appreciation, but I don't think that I deserve it. Okay, it's okay, it's okay. See the next one. The next question talks about a single conductor of radius 4 cm is designed by using a bundled conductor system having 4 conductors in each phase or the group. So what is happening here? The basic idea is, suppose this was your conductor. In the second case, you are designing it by using a bundled conductor system and you are breaking it into 4 subconductors like this. He is asking what is going to be the radius of each subconductor. So assume the radius of each subconductor is RB and assume that the radius of single solid conductor is capital R. Let us try to understand what is the concept here. Suppose I am giving you a general case. This single solid conductor you are dividing into n number of subconductors. This is 1, this is 2, this is 3, this is 4 and this is up to n. Suppose its radius is capital R and all these subconductors are having the radius RB. Now let me tell you, when you are dividing this single solid conductor into number of subconductors, all these subconductors are going to be acting in the parallel. Yes or no? You are just giving some spacing. So the voltage is going to be same for all of these. Here also voltage is going to be same. Suppose the current here is I, but when you divide it into number of subconductors acting in the parallel, the current carried by these are going to be like this, I1, I2 up to IN. So by applying the charge conservation, or you can say in one way you can say you are applying the KCL. Actually you are not applying KCL, but if the total current is I, which is divided into I1, I2, I3 up to IN, so you can simply equate the current as I1 is equal to I is equal to I1 plus I2 up to IN. Now you know that for the transmission line the current density is constant. So can you write the current as I is equal to J into A, where A is the cross sectional area? So if you put it in this equation, you can write J into A is equal to J into A1, J into A2 plus J into AN. J is going to be cancelled because it is constant. So A you can write as A1 plus A2 plus AN. Now if all the subconductors are having the same radius, so their cross sectional area is also going to be same. So can I say all these areas are going to be same? So can I write it as N times AB? Yes or no? AB is the cross sectional area of the bundled conductor, I am saying, and it is N times. Now what is this A? This A is going to be pi R square. This is going to be pi R B square. So if you simplify this, pi is going to be cancelled, and you can write the expression RB is going to be capital R upon under root N. Very important formula, you should always remember. Just by attending classes, whether my classes or any other good faculty classes, you can master power system. Okay? Just use this formula. In the question he is saying 4 subconductors are there. So how you are going to find the radius of the bundled conductors? Capital R. Capital R is given, yes, 4 centimeter. Under root N, what is N? Number of subconductors, that is 4. So this is going to be 4 centimeter divided by 2. So this is going to be 2 centimeter. So the answer is 2. Is it clear? Again I am asking, is there any KG fail in my class? If you don't comment in the comment section, it means you are the same guy. KG fail. So don't be a KG fail. Now see this question. This is the same concept question but little twisted question. He is saying there is a hypothetical 2 subconductor system which is again designed as a 4 subconductor bundled system as shown in the figure. He is asking the value of radius R3. R1 and R2 are given. Now please try to understand. If you understand this concept, whatever you are going to do with the bundled conductors, can you directly equate the cross sectional areas? Are you having this much, or you can use it? Please try to understand what is the idea. If you are going to write this, suppose the current here is going to be I1, this is also I1. Suppose the current here is I2, here it is I2, here current is I3, here current is I3. So can I equate the current? Can I write 2I1 is equal to, let me use the blue color. Can I write 2I1 is equal to 2I2 plus 2I3? Can I write like this? So 2 is going to be cancelled. You can write I1 is equal to I2 plus I3. Now again you understand, the current is current density multiplied by the cross sectional area, and current density for the transmission line is going to be constant. So directly you can equate the area, yes or no? Tell me in the comment section. Can't you directly equate the area? Yes. So how you are going to equate the area? You are going to equate the area as A1 is equal to A2 plus A3. Area you can write as pi R square. So simply I am writing as R1 square is equal to R2 square plus R3 square, because pi is going to be same, pi is going to be cancelled. Now he is asking R3. So can you give me what is R3? R3 is going to be R1 square minus R2 square. What is the value of R1 and R2? R1 is given as 2 centimeter, R2 is 1 centimeter. So this is going to be 4 minus 1, that is under root 3. And what is the approximate value of under root 3? 732, 1.732. Is it clear? What is the answer you are getting for radius R3? It is 1.732 centimeters. Is it clear, everybody? Just tell me in the comment section. So we are very close to the time limit, but because I have to deal with some more questions, if you permit me, if you allow me, and if you want it, I can extend the session timing by some more time, 10-15 minutes, so that we can complete some more questions. But it is only depending upon your choice. If you allow me, then only I can increase the bandwidth. So tell me in the comment section, you want it or not? Anyone? Okay. So Ashish is saying please increase. Rest candidates are not interested as usual. But let me tell you, whether you want it or not, I will increase the timing because I can decide. You can't decide, okay? You don't have the authority to decide. You just see what I'm doing. See next question, very easy question. A single phase transmission line has two parallel conductors 4 meters apart. The radius of each conductor being 2 centimeters. He is asking calculate the capacitance of the line per kilometer. The situation is something like this. The situation is something like this. Suppose this is A conductor and suppose this is B conductor and suppose the distance between them is D, like this. Now you must be aware, if you have attended my sessions, when we talk about capacitance, we have to talk about voltage. Without voltage, you can't talk about capacitance. Yes or no? You talk about the parallel plate capacitor, the most simple example for capacitance. Without voltage, there is no meaning of capacitor. Now, when you talk about the voltage, you have to talk about the reference. Because voltage cannot be absolute. You may be thinking you are very strong, but the moment you see somebody who is more strong than you, you feel weak. That is the same case with the voltage. If suppose in my class, one student is having a 5-volt battery, and I ask who is having the highest voltage battery, the 5-volt will say, sir, I am having the 5-volt battery. The moment he was answering the question, suddenly a 10-volt battery student is going to enter. Are you getting this or not? So potential or the voltage is all about relative understanding. So without reference, you can't talk about the voltage. And you must be aware, for this system, you will get a neutral point in between these two conductors. So we represent the capacitance of conductor A with respect to this neutral point, which we are writing as CAN. Similarly, we are writing the capacitance for the B conductor with respect to this neutral point, and this again we are writing as CBN. And the expression for CAN and CBN is same, that is 2 pi epsilon naught ln d upon r, and this is farad per meter. But please try to understand, this question is not talking about the individual conductor capacitance. He is talking about the, in the question he is talking about the line capacitance. This line capacitance is capacitance between conductor A and conductor B. And this line capacitance is nothing but the series equivalent of capacitance CAN and CBN. So all my friends, just tell me in the comment section, if you know ABCD of electrical engineering, can I write CAB as 1 by 2 CAN or equal to 1 by 2 CBN? Can I write like this or not? If I can write like this, I can write the line capacitance as pi epsilon naught ln d by r, and this is farad per meter. What is the value of pi? It is 3.14. What is the value of epsilon naught? It is 8.854 10 to the power minus 12. This is ln. What is the d value? The distance between the conductors is given as 4 meter. So this is going to be 4. What is the individual conductor radius? individual conductor radius is given as 2 centimeters. Now centimeter you have to change in meter to keep track of units. So this is going to be 2 into 10 to the power minus 2, and this is going to be farad per meter. So if you have calculator, you can use it and you can tell me what is the answer you are getting. Everybody just tell me in the comment section what is the answer you are getting if you can calculate. Can you calculate this? So this will be your answer. Are you getting this? If you don't do today's work today, then you will never be able to do that work. Because tomorrow will never come. Today you say we'll do it tomorrow. Tomorrow when I ask you, have you done it? You will say, sir, I told you I will do it tomorrow. So you will keep on shifting your goals. You will keep on shifting your timelines. That is not a good habit for a successful person. I hope you are getting this. See the next question. Again, a different construction, and he is asking the capacitance per phase. Calculate the capacitance of a 400 kilometer long 3-phase 50 Hz overhead transmission line consisting of 3 conductors of each diameter 2 centimeters. So what is the radius? The radius is 1 centimeter. Is spaced 4 meter at the corner of equilateral triangle. At the corner of equilateral triangle means the distance between each pair of phases is same. This is A, this is B, this is C, this is 4 meter, so this is also 4 meter, this is also 4 meter, and this is also 4 meter. So you can use the direct formula. Capacitance per phase direct formula is 2 pi epsilon naught ln GMD upon R, and this is farad per meter. Now I am going to give you a shortcut to calculate the GMD. Perfectly correct, Ashish. See this guy. Only one candidate is serious about the class, and just write his name somewhere. When the next year GATE result will come, I may be taking his interview as a top ranker. If you don't believe it, you just go to the spotlight, BYJU'S Exam Prep spotlight. There are 2 candidates who are in the top ranker, and they were very active and very disciplined when they attend the classes. For the previous question, Ashish is getting A option, 5.247 nanofarad per kilometer. Now I am going to give you a shortcut to calculate the GMD for any 3-phase system. Any 3-phase system. Listen, it may be unsymmetrical. It may be unsymmetrical like this. This is A, this is B, this is C. This is DAB, distance between A and B. This is DBC, distance between B and C. And this is DCA, the distance between C and A. It may be unsymmetrical spacing. It may be horizontal spacing. This is A, this is B, this is C. This is DAB. This is DBC. And this is DCA. Similarly, you can have the vertical construction. This is A, this is B, this is C. This is DAB. This is DBC. And this is DCA. Is it clear, everybody? Just tell me in the comment section. Now, whatever type of 3-phase construction like this you are having, you can directly write the shortcut. GMD you can write by using a shortcut, and that shortcut is you write DAB, DBC, DCA and take the cube root. The story is over. Whatever construction is there, this is going to be your final expression. You must be knowing generally we are using the horizontal spacing for the distribution system because we want to maintain the ground clearance. We are having the vertical spacing for the transmission system because transmission system we have to give proper distance in between the conductors because they are operating at a very high voltage. So you can write the GMD directly now. Yes or no? Because it is equilateral, 444 multiply and take the cube root, it will become 4. So this is 2, 3.14, this is 8.854 10 to the power minus 12 divided by ln. This is 4. What is the radius? The radius is 1 centimeter. So it is 1 into 10 to the power minus 2. And this is farad per meter. You can calculate this value. I hope you must be getting somewhere around 9 point something. No, Shivam, no limitation. No limitation. Are you getting that? You must have this much common sense. For example, if you are having one conductor in A phase, B phase or the C phase and you have different types of constructions or spacing possible, you can apply this formula. But suppose this is not a simple conductor, this is a, you are saying bundled conductor, then you cannot apply this formula. I hope you are getting this. You can only apply this shortcut formula if the effective distance between A and B, B and C and A is given. Directly multiply all these effective distances, take the cube root. The story is over. You will directly get the GMD. I hope it is clear, everybody. Tell me in the comment section. You must be getting somewhere around, I think, 9 point something. C must be the correct option. See the next question. Find the GMR of the following ACSR conductor when the fourth strand is steel. Now, very important concept. Very important concept. Very important concept I am giving you. While calculating GMR, steel strand is not considered because it does not carry any current, or you can say significant current. So if you are having a ACSR conductor or a standard conductor like this and I want to calculate its GMR, how I am going to write? GMR I am going to write as GMR1, that is GMR of first strand, GMR of second strand and GMR of third strand. Fourth strand is a steel strand, it is not going to carry any current, so I am not going to consider it for the GMR calculation. So GMR1, GMR2, GMR3. What is the proper power you have to take? Root you have to take. How many GMR are there? 1, 2, 3. How many GMR you want? 1. So what is the power? The power is going to be 1 by 3. Is it clear, everybody? Just tell me in the comment section. Is it clear? Now, can you tell me what is the GMR for 1? Can you tell me what is the GMR for 1? How you calculate the GMR? Effective distance of first strand. What is the effective distance of first strand? 0.7788. And the radius is same. Are you getting this or not? He is asking that each strand radius is, okay, each strand radius is R. So he wants to know what is the GMR in terms of R. So don't worry, no problem. We can use directly R. Now if you are writing the GMR for 1, what you have to do? You have to write the effective radius of strand 1 multiplied by the distance between 1 and 2 and 1 and 3, because 4 we are not considering. So what is the distance between 1 and 2? Can anybody tell me what is the distance between 1 and 2? Can anybody tell me what is the distance between 1 and 2? This distance. See, this distance is 2r. This distance is also 2r. So this distance is going to be 2 root 2r. So this is going to be 2 root 2r. Then the distance between 1 and 3. What is the distance between 1 and 3? 2r and 2r, that is 4r. So this is going to be 4r. How many distances are there? 1, 2, 3. How many distance you want? GMR is actually a distance. So it is, power is going to be what? 1 by 3. Can you help me write GMR2? What is going to be GMR2? Effective radius for strand 2, that is 0.7788r. The distance between 2 and 1 and 2 and 3, that is 2 root 2r and 2 root 2r, because this distance is also going to be 2 root 2r. Yes or no? So this is going to be 2 into 2 root 2r. How many distances? 1, 2, 3. Power is 1 by 3. What is GMR3? 0.7788r, that is the effective radius for strand 3, multiplied by the distance between 3 and 2 and 3 and 1. What is the distance between 3 and 1? 4r. What is the distance between 3 and 2? It is 2 root 2r. So this is again 4r and 2 root 2r. How many distances? 1, 2, 3. What is the power? 1 by 3. Just put all these GMR here and find the final answer. Is it clear, everybody? Just tell me in the comment section, are you able to follow this or not? Now, some of the questions I am giving you as part of your homework, and if you are not KG fail and if you are sincere, if you are serious about your result next year, start making actions, efforts. If you just keep thinking in your mind, I will be selected, I will succeed, I will do this, I will do that, nothing is going to happen. Even the deer, you know deer, in Hindi we call it hiran. The deer does not enter herself in the lion's mouth. The lion has to prey it. शेर को भी शिकार करना पड़ता है, हिरन खुद चल के उसके मुंह में नहीं आता है. So you have to make actions, make efforts. So do not forget to do the homework questions. You can take down the homework questions as part of your homework. Take the snapshot, and if you want, you can answer these questions. Answer these questions in the comment section of this video. I will tell you whether they are right or not, and if you have any problem, you can better join my Telegram channel. I will help you as far as possible. Second question. Direct formula, the shortcut for GMD you can apply and you can get the answer. This is a big question. If you are able to do it, then okay. Otherwise, in some class, I will do this question in front of you so that you can understand it better. So friends, this is all about today's session. Thank you so much for joining me live in the discussion. If you have any doubt, any query, personal, technical, whatever, you can join my personal Telegram channel, that is Electrical by Ashutosh Saxena. I will be more than happy to take up your doubts. Thank you so much for joining me live in the discussion. Take care of yourself and let us meet in the next session tomorrow, 8 p.m. in the evening, when I am going to discuss reactive power compensation, and that session is going to be extremely important because I am going to discuss very fundamental concepts related to voltage and power factor control, which is also called as reactive power compensation. So hope to see you again. Thank you so much for joining me live in the discussion. I will share the PDF in my Telegram channel. Do not forget to join my personal Telegram channel and subscribe to BYJU'S Exam Prep YouTube channel. Thank you so much. All the best. Stay connected. Thank you everyone. Good night.